way it's done. This is the way Mendel did it. So it's been done since Gregor Mendel first started doing this. So then, what's the question? If you have detached earlobes and are heterozygous, so this is you, you're heterozygous. And then once again, that will disappear after we get better at this. For that trait, and your partner has attached earlobes. Doesn't give you the genotype because you should know it just from it saying attached earlobes. What are the genotypic and phenotypic ratios of this cross? The most important thing, the way I grade these, I don't even look at the Punnett square. I look for these, and if they're right, I stop. Only like a math problem, if you miss this last part, do I look back at your Punnett square to see where you went wrong. Okay, and then I can give you partial credit. If you can go from this and tell me what these are based off, you're just really smart, that's great. But it's just like math. If you skip a step and you're wrong, I just mark it wrong. Okay? So in step 1, Taya, what's it tell you to do? On your worksheet where it says genetic problem set. So we're looking at our genetics problem set and it says step 1. What's it say to do in step 1?
Set up a cross.
Set up a cross. So the first thing is you. You are big D and little d. And then you marry somebody that has attached earlobes. Say that out loud, Joey.
Little d, little d.
So they have attached, so they have to be little d, little d. Does everybody understand that? What's it say to do next?
Make a
Yeah.
square.
Make a Punnett square. Step 2. Make Punnett square. Draw a Punnett square. Everybody fill that in real quick. On your separate piece of paper. When you're done with this, are you done?
No, you have to do the ratios.
Jacob Haller, what's it say step 3 is?
That ratio.
Write ratios. So the way we write these is you guys, I'll show you the shorthand version of it. Just write geno. That means we're going to write all the genotypic ratios below that. This is the only time I'm going to allow you. You know how to do this, Gabe? You all good with this? Okay. So Gabe, what's the genotypic ratios?
50-50. It's like halfway.
Of what? What do we call those? Okay, so pay attention to this. Let's go with Michael. What are these two genotypes called? That one and that one.
Heterozygous and homo.
Heterozygous. Say heterozygous.
Heterozygous.
So we write, how many of them are there, Michael?
2.
So we write 2 heterozygous. And then we put a colon because this is a ratio. Chandra, what are the other 2 called? There's a type.
Recessive.
Good. So we have 2 homozygous recessive. So those are the genotypes. Those are the little d, little d's. Don't write little d, little d. Don't shorten it up. I always get homo res. Homo period res. No. Homozygous recessive, or I get hetero period. No. You guys write them out. After a while, once you guys get really good at this, I let you shorten it up. So I'm trying to teach you the terms. So for a while, we're going to write these terms out until I go, okay, you guys can now abbreviate. We're going to be using these a lot. Okay, phenotypic ratios. So you write pheno. Underline it. And below that, we'll write phenotypic ratios. Willow. Big D, little d. Those are heterozygous. What is the phenotype expressed by those heterozygotes? Tall. No, not tall. Detached earlobe. So you got 2 detached earlobes. Colon. The symbol for colon, not an actual colon. That would be hard to draw. What's a colon look like? Yeah.
Is that a
Ashley, Little d, little d. What is the phenotype of little d, little t? Attached earlobe. Good. So we write 2 attached earlobes. Are we done?
No.
Sure we are. That's it.
Yeah.
Those are the answers.
Your little D in attached looks like an R.
Sorry. You try to write down there. Do you know what it says?
Detach you.
Yeah. Okay. Last practice one of the day. Here we go.
Great.
I'm not going to do that one. This is the, I don't want that one. That's fine. There it is. Here we go. Cleft chin. That's butt chin. Yes, butt chin. Okay. This is on my website, you guys. I want you guys to do this. This is it. Am I asking, the reason I show you this one, what am I asking for here? Am I asking for a phenotypic and genotypic ratio?
What is the genotype?
No, I'm not.
You're looking for genotype.
You guys, please pay attention to this, Sabrina. Know what I'm asking for. The reason I always go through this is because for a long time I'll ask you what genotypic and phenotypic ratios are. And then all of a sudden I'll go, I'll ask you, what's Bob's genotype? How do you know? And what's the probability that their next child will have a cleft chin? Anywhere in here, does it tell you to give me a phenotypic or genotypic ratio? So if I don't ask, don't do it. Answer the question. Okay, so now, I want you guys to read this. And I want you guys to see if you can figure out the answer. So I'm going to read it real quick. And I want you guys to try to figure this out. So in humans, cleft chin, that's butt chin, is dominant over having a smooth chin. Bob, who has a cleft chin, marries Sue, who has a smooth chin. One of their 3 children has a smooth chin. What is Bob's genotype? First question, let's just stop there. What is Bob's genotype? Talk about it for a minute. Think about it. We did it in the pedigree. You don't even have to do a pedigree. You can tell by the information given what Bob's genotype is. So let's go with Bob. First thing you want to do, I'll give you a hint. You got write down Bob, write down Sue.
Bob and Sue.
Second thing you want to do on these. What are they? Bob has a cleft chin. She has a smooth chin. Correct? This is where you get in trouble. What letters would you guys represent for this trait? Joey, what would you do? Yeah, what big letters and little letters would you use to represent cleft chin? No, I don't care. What letters?
C.
C?
E.
C.
What would you do?
I didn't read.
E? E's smart.
Wow.
That's a very good, because, okay. Is that a big C or a little C? It's a little C? What is it now? C's are ambiguous. You cannot tell if it's a big C or little c by looking at it. You guys understand that? Same with S. Is that a big S or a little s? It depends on the size of the next S you draw.
Smaller.
Yeah, so we don't know that. So E's are smart. So let's say that this is cleft and this is smooth. See how you can tell the difference between the capital and the lowercase letter? That makes it easier to deal with. You can use whatever you want. A's. Just as long as you can distinguish between a big letter and a little letter. Just bad letters. Bad letters. X's are bad. S's are bad. C's are bad. T's are bad. But I make my
Not
small
really.
t with that loop on there so you can tell.
M's and W's.
Yeah, W's are bad. Okay.
What?
So, from this information, we know right away. What is Sue's genotype? Who can raise their hand and tell me what Sue's genotype is? Look at it. She has a smooth chin. It's a recessive trait. Sabrina, what's her genotype? Lily. Okay, from that information, do we know what Bob is?
No, yeah.
But from the children we do,
Yes.
because they have 3 children. We know Bob has a cleft chin and it's dominant. So Bob is either this or that, correct? He's
He's
one of those two. We know that for a fact, right?
He's
Either one
all
of those will be a cleft chin. So let's look at their three children. Three children, one of them has a smooth chin. One of the children has a smooth chin. So one of their children is a little e, little e. Mommy gives a little e.
And Daddy gave one.
So Daddy has to be that, because Daddy has to give that little e. Does everybody understand? He will be heterozygous.
So wait, if all his children, if all three of his children had children, he could still be heterozygous.
He could still be, but we couldn't tell for sure what he was.
Exactly.
Yeah.
Yeah.
Nope. Yeah.
There should be a way to like figure that out.
Doing a genetic makeup. Okay. Are you done?
no.
So now, how do you know that? So you would just say in words that Bob had to be heterozygous because he had to pass on the recessive allele. So he had to have that to be able to pass it on to one of his three children.
So we'll make the fourth child.
So then after that, what's the probably their next child would have a cleft chin? How would we figure that out? Stand down. How would we figure that out? Willow. Use of the boxy thingy. What do we call the boxy thingy? A Punnett square. So we make a Punnett square. Let's put Bob on the top. Let's put his sweet wife on the side with her smooth chin.
Wow.
Wait, how does the second box?
I screwed that one up.
Yeah,
And
you did.
There we go.
Now you screwed me up.
It's a, what?
0%.
Do it for yourself. Quick copy.
0%.
So, he is that heterozygous because he passed through the...
Because one of his child had a smooth chin. They had to be little e, homozygous recessive, so he had to be heterozygous to pass on the recessive allele. You understand that? Okay, what is the probability their next child will have a cleft chin?
No.
50.
50-50.
That'd be nada.
50-50. Does everybody understand that? So now was that as hard as it looked when you started out?
No.
Okay, now I'm going to give you guys the reprieve of the century. Those on the second page of this worksheet, where it said incomplete dominance, and then there was a dihybrid cross on the back. Don't worry about those as of right this second. Okay, so worry about the first page and the second page, and this we'll get to next week. On the test Friday, we will only do these types of crosses, which are called monohybrid crosses. Okay, so dihybrid, I gave you those to make you panic. How many people understood them?
I understand them.
I got
But if you start looking at them, when we get into them next week, you'll be all, you kind of get this, and it'll come a lot easier. That doesn't mean simply ignore them. Alrighty, so no, I'm not done. Give me a couple more seconds. The rest of these questions, there's 6 total on this PowerPoint. Quiet. Please
Shut up.
stop talking. Give me a couple seconds. There are 6 questions total here. This is great practice for the test that is coming up on Friday. This is, all of this stuff that you have is not new. Ever. What it's for is for practice for the test that is coming up. I will be here at lunch every day this week. If you don't understand something, but I'll tell you, come in and see me. But if you don't do these, you are going to be in big trouble as far as this. These will prepare you completely for the test on Friday, minus the DNA structure stuff, which I'm going to give you more of on Thursday. Okay? So these are not due at any point, which you guys should have never turned them in. It is in preparation for the study that's coming up on Thursday and the test on Friday. If you say, I got this, Mr. Barnes, no you don't. Do it. Because the information from the article will be asked on the test. The information from the worksheet will be asked on the test. The information from the Punnett squares will be asked on the test. So that is the majority. DNA structure, a very small part of the test. The test will take the entire 90 minutes on Friday. Okay? Any questions? You guys are awesome. Thank you guys for the good questions. Good job.